Hey, hey.
It's class time.
Yep. Nice. The Travis Scott meal from McDonald's? No. I also have no idea what the biggest file you can upload in Zoom is. Probably like a gig or something. Please don't start using my Classroom as a file sharing utility for videos and movies and stuff, pirated resources. I'm sure nobody has any of that. Couldn't you just link to your Git? 512. Not bad. All right, so today we got to talk about scope and some function stuff. And hopefully that'll get us far enough along to where you guys will feel mildly comfortable about the project. Looking back on what I had in the second example in the project code, the only reason that second init, yes, project 2 is moved to next Wednesday. So in the second set of example code on the project page, there was an init here. The only reason this was there was because the code sandbox thing that we're running in does not like this window.add event listener. That's the right words. So to get it to work in that little sandbox that it was in, we needed to call init ourselves, but you should not call it yourself here. You should just have the add event listener with the init passed in. So let me use this code as a quick example to talk about some scope. So there's a couple of different types of scope. There is, and there's a better, if you go look at the JavaScript, the language, there's a really, really good scope overview here in the JavaScript, the language docs, and it takes you to this whole long list that talks about how scope works, how you can get it to work for you, against you. Yes, it does use vars everywhere, but I'll just try and talk a little bit through some of that. There is basically global scope and then local scope. And local scopes will build themselves up into a chain. So in Sublime, at the top of our code, we have these two global things. They're global because they were not declared inside of a function. Unlike other languages like C++, regular C, Java, I think even Python and stuff like that, In those languages, pretty much everything that is a curly brace creates a new scope. So like if you do something in a curly brace and like create a new variable inside like a for loop or something, it will not exist outside of that scope. That's not really how scope works in JavaScript. The only thing that creates a new scope context is a function. That's it. That's all you got. So it's either global scope or it's function scope. Let actually tries to protect you from accessing things outside. I believe it does anyway. Let's try. Let's see here. If I have for I equals 0, I is less than 3, I plus plus, and I do, now this should work, var j equals I, and then down here console.log j. Okay, so we actually get a 2 there. That's awesome. For I. No, I don't want to use I because I'm using I inside the function. Okay. But if I use let, and let's change this to k, and then down here change it, let me make this a little bit bigger actually. Let's change this to k. Where's my cursor? Just k. Then we get an uncaught reference, k is not defined. So let actually, while scope is still only created in functions, let is at least a little bit kinder and will throw an error because it doesn't exist. It gives you a little bit more control over your scopes. So if you define something inside of it, but unfortunately, if I do something like this, I don't know if this will work. Let k equals 12. Okay, so let actually fixes scope to work inside for loops and stuff. Good to know, but var will just exist. So if I do var, let's go back and do, yep. And var j, this shouldn't work. Let me make this x, and then var x equals 12. Still says 2. Oh, because I'm console logging j. Okay, so that works too. So var actually ignores the for loop scope, I think. I don't know. Just, yeah, scope is always functions. Don't worry about it. You can use it inside for loops and stuff like that. Maybe they fixed the language since I started teaching this to where you can leverage a little bit of scope inside for loops. But for the majority of things, you want your scope to, you just consider your scope to always be inside functions. So this is a scope. This is another scope. If a variable does not exist in a scope you are in, it will look up the scope chain. The top of the scope chain is always global scope. So inside here, we aren't defining root node in here, because then if we wanted to access root node up here, like that, then if we had something like let root node there, then this one would be undefined. Who's calling me? Oh well. All right. So if we define the root node here, then we're saving into a local variable called root node, and it won't look up scope to save into this global variable root node. So then if we come up here, it's not going, root node will just be undefined. So by removing the definition of the variable here, we're only doing assignment, because when we do it this way, we're doing variable declaration or variable definition. We're defining the variable here, and we're doing the assignment to it. So this is a compound statement, just because we're creating it and writing stuff into it. That will become way more important a little bit later on when we talk about hoisting, which is something that you hopefully will never have to worry about because you're never going to use the var keyword, right? So if you never use the var keyword, you're never going to have to worry about hoisting. But another thing about scoping is if in here I define another function, let me actually just go read some of their docs because they do it better than I do. So let's close this. So we have, and they have vars here and everywhere, that's great. So they define a variable here, Todd is defined. They can console log it. And then outside of that function, it is not defined. Makes sense because out here we're in global scope, we don't have access to the scope inside this function. Also, scopes chain. So if you create a function inside another scope, so just like this function was created, where it was created inside global scope. So if it does not find a variable in its own scope, it's going to look up the chain, and that chain is just one link long, and it's going to find it in global scope. Here, this function is created in global scope and has access to global scope variables. This function was created inside the first function's scope, or was created inside scope B, a local scope, scope B. So this is global, this is your first local scope, this is a second local scope. If it doesn't find it here, it's going to look up into this scope, and if it doesn't find it there, it's going to look up into this scope. If you define a variable in here, it won't be accessible anywhere else, but you can access, read and write, and all that stuff to variables that were defined in any of those other scopes. So when you define a variable, you have to be conscious about where you define it. Not a variable, well, yes, a variable, but also a function, because functions inherit scopes. So here's an example. They create a variable called Todd in scope B, and then they create another function and name, okay, the variable is name, the value is Todd, but yes, name is accessible here. That's what I was just saying. If you guys want to try any of this, the link's on the page. You can go over to it. You can paste these things into your browser console just like I do, and it should. So if I take all this stuff and I go over here, it didn't copy. Why not? Okay, and then I need to call. So what's funny is I won't be able to call any of this. Let's return. So I need to do return my other function. So we're returning a function pointer there, and then now I can call my function. And it returns a function, my other function. And so if I take that and save it into a variable, if I call f, it's not going to work because this actually doesn't console log anything. Wonderful. Okay. So let's redo this. Let's do console.log name. Down here, we'll say f equals my function, execute my function so that what gets saved into f is the return value because we're using the parentheses here. Right? So the parentheses means we're executing my function. My function returns a function pointer, which we're saving into f. And then we're going to execute f. And we get Todd. Okay. Good times. What else do we got in here? And this is kind of a long document. I don't know how much of it I want to go through today, but you should all try and understand all of this, and it may be useful for you on the quiz today. I'm just saying, you're welcome to have this page open and try and understand it while you're taking the quiz. Good luck with that. So, yep, because we declare it globally, okay, all that makes sense. We declare it in here. It's not available anywhere else. That all makes sense. And then they get into scope chains. Yeah, okay, so that's what we were just all talking about. Awesome. Closures. Closures tie in very closely with scope. So here's an example of a closure. Actually, we just had an example of a closure. What we did down here, where we create a variable called name, right? And it is inside my function, and then it gets used inside my other function. So it's called a closure because this variable exists here, and then this scope goes away. The scope is no longer accessible, so there's no way to get back to this variable. But the function that we created inside this scope still has access to that variable. So we've now closed the scope. We've wrapped the scope up like a tinfoil ball all over this variable. And now the only thing that can talk about this variable, access it, read to it, write to it, is the stuff in the function that we returned. So this is called a closure. Yeah, and you have to return a function for closures to work. And by the way, that means that anything else you've defined in this function scope stays around in memory until this whole function pointer goes away. So if you defined like a 5 megabyte string or an entire Git repository or something like that inside this scope here, and then you save the return of this, so save this return value into a variable so you can call the function later, awesome. The compiler you can even delete this whole function pointer, and the variable is no longer accessible anywhere else except for inside this function. But as long as this function exists in memory, that 5 megabytes or your whole Git repo that's 512 gigs or whatever the hell, it will all still be in resident memory of your browser. So that's a little bit of something to take with a grain of salt. When you make closures, you kind of need to be sure that you're like not saving too much memory. Although really nowadays, like, I mean, what, I got like 32 gigs of RAM, so Firefox takes up kind of half of it, but you know. Say hello, Todd. Yep, okay. So this is what we just did. We saved the response of say hello, which is its own function. Thank you. Yes, hello, Todd. And we can one-line it. I didn't do this, but yes, this makes sense, right? So this returns a function pointer. Okay, so this is a function pointer. These parentheses execute the say hello function and pass in Bob. And then it returns something right here. It returns another function, which we then immediately execute. All right, so this is the one-line equivalent of this stuff up here. Cool. Yeah, AngularJS does the same sort of thing. By the way, this is called, I think it's called marshalling or something like that. Which I hate doing, and every time I see it done, not this specifically, but there's something where if you have, like, you need to have a function that's called, like, you know, function for f equals function, and this is just going to be like arg1, arg2, arg, you know, all the way out to like 25, right? And so you have this huge obnoxiously long function, and then if you want different parts of your program to be able to attach different parts of these arguments, like let's say one layer of your code only has access to arg1 and nothing else does. Another layer of your code only has access to arg2 and nothing else does. Then you can try something like marshalling, where you would call f arg1 and then arg2 and then arg3, and so each 3 and then all the way out to 25. So each one of these things returns another function pointer, just like this compile template scope thing. And there's a pattern that you can employ that I really hope you never do to make this work out, where it's just like, okay, well, we'll just adjust what gets returned so that the next function pointer is a closure around arg1, and then the next function pointer is a closure around arg2, and a closure around arg3, and then finally when you get out to arg25, you have everything wrapped up nice and tight. You can actually run the underlying function that has 25 arguments, and it'll read up all those closure scopes, the 25 different change scopes that are all closured, to try and to find all those arguments and actually run it. Currying, thank you. Yes. What was I thinking of? What is marshalling? I don't know. I hate it, so don't use it. Currying is terrible. I don't really care. You can be annoying and write code with currying if you really want. I don't, you know, I'm not going to take points off for it. It's just going to be hard to read. Marshalling's with JSON. Yeah, okay. You see, I learned stuff too. You guys are great. All right, so yeah, this is pretty much what we were just imagining it would be. You just keep returning new functions. Am I going to talk about callbacks and promises? Yes, I'm getting there. Give me a little bit of time. I'm not going to talk too much about promises today because promises almost deserve its own class, like its own hour-long discussion. I just want to get you guys comfortable with callbacks and why we need callbacks in JavaScript, which is part of what I'm going to talk about today. And yeah, yeah. Okay, so yeah, we kind of get all this. Here's a set timeout. Okay, so this is what we call a callback. All right, there are other names for this, but I guess I can dive into this right now. I was going to try and tackle this at the end of class, but the short and sweet part is JavaScript single-threaded. It only ever runs in one thread. There is no way to, like, for example, C++ or PHP or something, just do a sleep or wait or, you know, get off the processor for a little while. When 5 seconds comes back, it'll pop back on, the thread will pop back onto the processor and everything will resume running in your logical flow of code, right? There's no such thing as that in JavaScript. If you wanted to try and if you were naive and were like, well, fine, I'll just make a while loop that, you know, counts to 1,000 and that'll give time for things to happen. Because it's single threaded, a while loop that runs for a very long time will freeze up all other JavaScript in that thread, which generally speaking is your entire tab, or maybe all the threads in your browser, depending on how your browser implements JavaScript threads. So yeah, while loops, just busy waiting, not an option. So the only thing you can do is you can provide a different function that says, hey, when some event happens, call this other function. That's already what we're doing with the onClick stuff, right? So if we go look at our onClick code, this is a callback. And so is init. This is a callback, right? So it's a function primarily, but we're using a function as a callback because whenever we use a function pointer as an argument, generally speaking, it's a callback, kind of. Especially if we're like, hey, I want to wait for something to happen and then run more code, and so I have to pass you a function pointer. That's what a callback is, all right? The reason we have to do that, again, is we can't just sit here and do while window.notReady. You know, that's just going to busy spin, right? That's not going to do us any damn good. It's just going to freeze up everything. Or while not window.ready would probably make more sense there. So that's just going to freeze up everything, and it would probably make the window never ready. I'm not sure, but I have a feeling that it would just sit there and actually take up all the resources so that the window can never actually finish computing itself to get ready. And if we were to try and add like some sort of sleep or anything like that, these commands don't exist, right? Like there's no sleep 5 or sleep 6 or whatever, and then continue our execution path in a straightforward manner. There's none of that. It doesn't exist in JavaScript. So if we wanted to wait for something, we would have to do something like, oh God, how would we do this? I'm not going to write this in this window. Let's do it over here. Function. Oh, I don't even know what a good way to do this is off the top of my head. Waiter equals function. Yep. Okay, so it would kind of have to be recursive, right? So I think we would do this, and then we would do if not window.ready, and I don't think window.ready, don't quote me on that. I'm just kind of pseudocoding here. That might not be a thing. Set timeout waiter, comma 1000. So that's milliseconds, all right? So every 100 milliseconds, every 1/10 of a second, you know, that's if we pass 100, if we pass 1,000, it'll be every second, it'll call this code. And then we actually have to kick it off, so we'll just put the same code over here. And this will pretty much, this is our callback-centered way of doing this. Now, it is recursive, and so that's not great, and I think there is a non-recursive way to do this. but I'm not sure. I can't think of it off the top of my head. I think there's a, oh, there, instead of set timeout, you can use like set interval. Yeah, that would work because set interval returns a handler. So this is recursive. That's not great. Instead, I could be like const better waiter function if not window dot ready. Yeah, that didn't work. And then we also have to define a const int reference equals set interval. Pseudocoding the hell out of this because I can't quite remember how this works. And then 1000, and then up here we just say if, instead of if not, we say if it's done, if it is ready, then what is it, stop interval? Set interval, clear interval. Yeah. And we could even say like, okay, yeah, so that would work. And then we may want to also do like int reference equals false, just to make sure that everybody else using this thing knows that it's no longer a thing. So this is a cleaner because set interval will just call it every 1000 seconds until we stop it from getting called. It returns a handler. Set timeout also returns a handler, but since it only runs once, most of the time you don't really care about the handler unless you want to abort it before it goes off, which works fine, you know. So this is a you know, non-recursive way to do it because it's not calling itself. We just have set interval calling better waiter every 1 second. And then when we finally get to the condition that we want to stop it from calling it, we just clear that interval and we're good to go. Okay, so that's a little bit about callbacks and kind of sort of how we want to use them. Let me make sure I've gone through as much of this as I want to. Changing scope with call, apply, and bind. Call and apply, I'm not really going to worry about too much in this class. All three of these are sub-functions that exist on the function pointer. So let's talk about blah, 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 don't care, call links. Yeah, okay, doesn't really matter. So you can add event listener, blah, blah, blah. Yeah, okay, don't care. Okay. Where is the, okay, here's the dot bind. All right, so I'll get back to dot bind in a minute. All right, I'll talk about bind. I didn't switch over to the browser. Sorry. So here we have some like, why did I just put that there? Like we're halfway through this thing and we don't know what invoking function is. Okay, so most of the time a function has a scope variable. Arrow functions do not have a scope variable. The two main differences between arrow functions, which I'm going to talk a little bit about in a second, it's good to talk about it now. All right, back to Sublime. Okay, so this is, as you know, this is a regular function. You can define it this way, and you can save it into something. If you define it like const f equals function, my function, that also works, and this actually gives the function its own unique name. That name is easier to debug in some ways, because if you get an error while running f, so if I stop that, get rid of that, and say f, right, and there's an error inside here, it's going to throw something that says like, hey, an anonymous function threw an error or something like that. This is anonymous because we haven't named it. It is saved into a variable, but as far as the JavaScript engine is concerned, it is not by itself a named function. Now, if we have something like this, or we can even do this, this is valid. So this gives it a name, and then if we have this in front of it, it has a name, and it's also saved into a separate variable besides the name. So without the variable part, we can still call my function. And that should work. And if we have const f equals in there, then we can both call my function and we can call f. And either one, if there's an error inside there, it'll say, hey, there's an error inside my function. Even if you call the f one, it'll say, hey, there's an error inside my function. Pretty sure. Let's test it. What if I do like let f and let, not f, let x. Let's see if that'll even work. All right, let's see if that'll even let me do it. Nope, syntax error. Wonderful. Okay. What's a good way to break? Oh, doesn't matter. I can't think of a good way to like break during runtime at this point, so screw it. All right. So yeah, these will both break, and they'll have like, hey, this is an anonymous function that has a name. Cool. So inside regular functions, there is no. I already told you guys that these arguments here, and I'm just going to get rid of that because most of the time everybody writes code like this. So there are no arguments inside here. I already told you guys that we didn't have to have what is it, like types for each argument. We don't have to say like int x and string y and stuff like that. We can just put like x, just put like a, b, c, and it'll create these three variables. So I can do console.log a, comma b, comma c. And if I call it f, this is a, b, 12, and let's copy that and run it in the browser. Just refresh that to clear out my scopes. This is A, B, and 12. So it console logged all of those things. Awesome. So what happens if I pass in an extra one? This is extra. Anybody, this won't actually break JavaScript. JavaScript's totally fine with this. Well, okay. Well, it's not totally fine with me redeclaring f, const f, but this is, with a comma. This is extra. Okay, and so it works just fine. If I want to redeclare it, let's say I remake this function again, and I don't put any arguments in there. And I can try and console log A, B, and C that way. And then I can call this function at the end. Okay, I can't, because it's a const, right, F2, fine. I'll do let F2 so I can keep actually doing this. All right, so reference A is not defined. So we tried to console log A inside the function. A didn't exist in the function because we didn't declare any arguments. But, let's redo this again. There's a special keyword inside functions called arguments. Arguments will always exist as long as you do this type of function. Argument student does not exist. The special arguments keyword does not exist in arrow notation functions, but 0, 1, 2, 3. So 3, 2, 1. There we go. So it logged the same thing that we wanted. In fact, it actually logged the fourth thing. So we didn't make any of these variables. We didn't ask our function as arguments to create those variables for us, but the arguments still exist. So what's the whole point of even putting arguments into this thing? Well, if we want to just never use arguments, I could do the exact same thing that arguments do. Let A equals arguments 0. Let B equals arguments 1. And then down here, and just all of the arguments just there so we can see it all. Okay, so this is pretty much what JavaScript's doing under the covers. When you declare an argument in a function, it just puts these extra lines of code into the top of your function for you. So it defines these variables in your function's local scope, and based off of what position inside these parentheses that you define those arguments in, they get pulled off of the arguments list. So pretty cool. We can also make functions that take an infinite number of arguments, kind of like console log, right? So console log, we're just, even here, we can pass in 3 comma separated arguments, right? So that's 3 different arguments. We can pass in 25 arguments. We can pass in just 1 argument. Console log will dutifully log all of that stuff for us because under the covers, it doesn't have arguments defined in its function definition. It just uses the arguments keyword and probably just for loops over it or something like that. The other thing that functions like this have is the access to the this variable. So if we go back to Sublime, I think, project 2. Okay, so here we're using the this variable. This variable is actually probably well explained by the document, the scope thing that that I was reading through earlier, but I'm going to give it a shot and then we'll see what that thing says. So when we attach a function to an object, so this button is an object, right? It just lives inside JavaScript. It is a copy out of the DOM tree, but it gets converted into an object inside our JavaScript like memory space when we do document create element or document get element by ID. So natively it lives in some like C++, a very, very compact and efficient memory structure inside the browser. But when we invoke these sort of document calls, it converts it into a JavaScript element that's available to us inside our actual JavaScript namespace. Our JavaScript interpreter, I guess is the right word. So when we assign onClick to this button, when the button gets clicked, it pretty much inside itself says like, let's say like inside the button, it's like, hey, if I got clicked, this dot on click, and then some event object. Because yes, it passes you an event object even if you never use it or define it in your onClick definition. There's still a couple of arguments, at least one that gets passed into your onClick. So inside the button, it's calling this dot onClick on itself. And when it calls this dot onClick, the scope of inside here gets set to the button. So this is the button, right? And when we assign stuff, these extra things to the button, because if a button is just an object, like an object is a key value store, we can put whatever arguments or keys and values onto this thing as we want. So I just made up row and column. You could easily call it X and Y owned. Some of them are special, like inner HTML. If you write into that like this, then it actually sets the text inside the button. Cool. Some things might not even be writable. Some things you can only read from. Some things are functions that you probably don't want to overwrite. But row and column and owned, they don't exist on the button naturally. So we can just like, hey, I'll just add some more keys and values to this thing. So I added a row and a column, and whether it's owned, and then we write the onClick into it, which is a special thing so that it calls this onClick. And then we have this, and it works. And we can access all of the things that we put onto the button, and everything's grand. The this keyword and the arguments keyword do not exist in the other type of functions, which is kind of my favorite type of function. So eventually all the code you're going to see, and even some code you're going to see on the quiz today, const f equals arg1, comma, arg2, and then fat arrow with an equal sign, not a hyphen. You got to use an equal sign and not a question mark. And then you write your code here. Right, so I can console.log arg1, arg2, and this does not exist. Arguments does not exist. And it may even throw an error if you try to use arguments. So let's call this F, I don't know, arrow F, right? And let's try and I bet you console.log this will probably either say null or error, and console.log arguments. All right, so, and then let's just execute it here with this little print, so that'll work. All right, so if I do that and go back to the browser, what is the difference between using arrow and not using it when creating a function? When you create a regular function, the this variable is accessible, and as you copy that function into multiple buttons, the this will be different for each button you're running on. So in our code, we had 9 buttons that we were creating. We had just one on-click function. Every time we attached it to a new button, this became the button. That's awesome, but it has a lot of unintended side effects. If you have a function that you need to have access to a specific scope and a specific this variable, and then it gets attached to somewhere else because somebody else was on your project and they weren't as good at coding as you, or they didn't understand that you were doing something special over here, then all of a sudden you're not going to get the this variable that you wanted, and you're going to get some weird interactions, and it's going to be pretty hard to figure out, like, wait, why the hell is this variable changing halfway through? Oh, it's because this function is using a this keyword and it's attached to the wrong thing, and so the this keyword is actually overriding something in the object that we don't want it to, or something like that. So fat arrow notation. What? What did I? I'm caught syntax error. What did I wrong? What? I mean, that should work, right? Did I miss? Okay, let's try this. Arrow F2, because I declared it as a const. Let's declare it as an let, just so that we can do it. And then enter. Still busted. Am I doing this right? Arrow functions. Yeah, Oh, it did work. Did it throw a different error? Oh, no, it didn't throw an error. Okay, we didn't execute it yet. Arrow F. See, I'm like getting ahead of myself. Trying to get as much in the next 10 minutes. All right, so if I call this, we get undefined, undefined. We get, it does print out the window because where this was defined, it was defined in global scope. So this that we use here is global scope. We can access it. We're just, can I spell arguments right? Okay, so we can access the this variable, but if we attach it to a button, this variable never changes. So fat arrow notation has a little bit of protection. It does not let the this variable get overwritten whenever you attach it to another object or anything like that. It is set in stone. Wherever you create it, that's where it is. There's nothing that can change that. And then arguments, you just can't use arguments at all. So where are we? Let's close. So we called arrow F, and it printed out the scope that we were in, and it says, hey, arguments is not defined. It doesn't create it. It doesn't give you access to it. If you want to access variables that are not in your argument list, you're going to have to use a regular. If you want to have a function that can access an infinite number of variables, you're going to have to use an actual spelled out function, not an arrow function. But it also means that, like, these are both protections that make sure that you're getting exactly what you want. And if somebody else, I wonder what happens. Let me see what happens if I pass in. Well, it probably just won't do anything. So let's do arrow F2 equals arg1, arg2, and then console.log arg1, arg2, F2, and then let's do A, B, C. So it's only ever going to log A and B. If you put something else in front of it, if I were to try and say, oh, well, I don't want it to log A, you know, if I want to put like Z in front, it's just going to log Z and A. And the first two positional arguments are the only ones you can ever access inside an arrow function. If you want more, you have to change your function definition. Okay, So back to this stuff. Now we're talking about .call, and we have .call and stuff. .bind is actually really, really useful. So if we go back and we look at, okay, well, how would we do an on-click? How would we do this here? How would we do this on-click as an arrow function? Like, I need to be able to access the button that it's in. Like, how am I supposed to do that with if I wanted to use an arrow function? Well, then we get to use something called bind. So if I make this an arrow function, I'm going to make it take the button in as an argument. And you may be thinking, well, hey, we aren't calling it, the button's calling it. So how can we influence what gets passed into this thing? And so let me just do this button and replace, and also do it here. Okay. So now we have this here button, or this on click, and it has button as an argument. It's the only argument we can't access anymore, can't access any less, but we aren't the ones calling this function. We aren't calling on click, the button is. So how do we get the button to pass itself in instead of setting its scope? And by the way, this here, if I console.log this, it will probably still be the window because it can't be changed. So even though it's attached to the button down here, this won't change. It's still accessible though. All right, so we have to actually make a new function. So I'm going to do it the hard way. Let's do something like, down here. All right, so doing it by hand, this is what bind does for us, or at least the arguments part of bind, but because bind will also try and set the scope. If you do bind on arrow function, it'll try and set the scope, it won't stick. So, but yeah, bind requires both the scope and whatever arguments you want to attach to the function. So let me do like let wrapper equals, and I want to pass in, I don't want to pass in anything, and I need to return function, and inside this function I need to call on click. And then inside here, I do need to take in, what do I need to take in? Just the button. Okay. And here I need to pass in button. All right. And so here, instead, I'll call wrapper, pass in button, btn. All right, so what this does, this creates a closure. All right. So we have this external function called wrapper. It takes in an argument. This argument now exists everywhere inside the scope as button. So when we call on click, even though it's in another function inside of it, button doesn't exist inside this scope, but it does exist inside the scope that the function was created in. And so we can even do something like this if we wanted to. This won't influence things, that'll work too. All right, so all this works. We have two fat arrow notation things, right? So we have the outer wrapper, and we have this inner thing, and now every time we do this on click thing, it creates a new function pointer. That new function pointer has a closure with the button in it that we've passed in. Why can't you just say button on click equals on click button? Because if I put on click button here, it's actually just going to call our on click function, and our on click function doesn't return a function pointer. It doesn't return anything. So what gets saved into button.onClick here is undefined because our function doesn't call, yeah. So we have to basically trick or make a new closure wrapper around our function by doing it this way. And so that's the hard way to do it. The easy way to do it is .bind doesn't, we can put like 0. So this first argument in .bind is the scope. We can't change the scope of arrow function, so it doesn't matter. We can put false. We can put this. Put null, undefined. Pretty much anything. We can put whatever we want in this first argument. And then every argument after that, get rid of that. Every argument after that, so button, and then like maybe C, and then maybe some like random string. All of these will be arguments that get passed into this function. So this does what we just did. This creates that wrapper function and calls it for us and returns a new function pointer. And that new function pointer tries to apply a new this scope to it, which doesn't work, doesn't break, but just doesn't work. So this one, if you're using fat arrow notation, you can do whatever you want with this. But the rest of these things are arguments that get passed into our button, and they always get passed in as the first arguments to our button. So let's say, and we already said that on click, when a button on click happens, it passes its own event in. So click event, right? So if we get rid of these because we don't need them anymore, if we still want to get the click event, this bind doesn't override it. It just shifts it down one. So whatever we put at the front, let's say we also wanted to put like row and column here, right? We can put those there, and then up here we have to shift this down, row and column, right? And so we can pass all of the variables we need. We don't even need to save them onto the button, all right? So it's pretty cool. Now, if you're not passing it, if you're passing in like a non-primitive variable, like an array, and you're building up that array as you go, like let's say we had an array that we were building up here inside this for loop, and we're adding stuff to it as we went. This is just a reference to that array, right? So the row and the column, those are you know, they're not references. They're primitives, so they're passed by value. But the button, that's an object. So whatever changes we make to that button, what if we, you know, 5 iterations of the loop later, we make some changes to that button, it will actually be changed up here because now we're at a later point in time. So kind of think about what you're doing with reference type variables when you do this. You may want to like copy it or clone it or something like that. For what we're doing here, it's fine because we're actually grabbing a new pointer to a new object every time we do this, right? So at this iteration, it points to this object. Next iteration, it's going to point to a new object that we just created. Next iteration is going to point to a new object. And so this pointer is different every time. So we're not modifying the same memory on the same thing. So this pointer is going to be different every time it goes through the loop. Okay. I think I need to go in about 2 minutes. That's arrow functions. Let me make sure I went through everything that's kind of going to be on the quiz, or that I haven't gone over yet that's going to be on the quiz. Where is that? Boop, boop, function arguments, scope basics, arrow functions, hoisting. Okay, hoisting. Quick thing on hoisting. When we have a scope like we have here, so you can do it either way. If you use an arrow function, you have to use the dot bind. But if you use just a regular function, open, close parens, like up here, as you're on click, then this variable, the scoping variable, the variable called this, will change as you attach it to new buttons. So either way will work, but you can't leave this as an arrow function and then expect it to be able to use like this dot inside of it and expect that to be the button that we have down here. So there's 2 different ways to do it. This is the fancier way, right? So if we have this, and let me just get rid of all this and clean it up. This is the fancy way because we're actually using bind and we're using closures and stuff like that. Awesome, that'll work. If you want to use this dot like the original example, then this has to be a function. With an N before the C. All right. And then inside here, you can use this dot row, this dot column, and all that will work because you're actually, and then this can just be on click without the parentheses. Don't execute it. So that would work. All right. So the second example in the project description code, the one that has the weird extra init at the bottom that you should not keep in there, but don't worry about it. That second example has it written with using thises and an actual function. That works fine. I'm not going to take any points off for that. I don't think I ever require you guys to use arrow functions, but as we get further and further on, it will become like you're going to need to use bind. And if you're using bind, and we don't really use this very often, it's just less keys to type, right? So if you're typing up your code at 11:59 at night, you may want to save yourself the keystrokes. And so arrow notation is, I don't know, I like it. It reads cleaner to me, but you don't ever have to use it, in my opinion. Quick thing about hoisting. I told you guys that when it's a compound expression, that makes sense. Thank you. You're welcome. All right. So quickly now, if I do let a equal 23, I told you guys that this is a compound expression, and let's say up here I do, and I don't want to use let because let actually saves us from doing this kind of. So I'll just do this. Screw it. I'll do this down here. Okay, so new section of code. All right, forget about everything up there. Var a equals 23. This is doing two things at once. It's creating the variable a, and it doesn't need to be in the function as I talk about it. Const h equals function. Just so that we can get some scope action in here, because hoisting's all about scope. I'm going to call this let because I'm sure I'm going to need to save over it as I modify it. All right, so console.log a. We all have a good idea what this will do. It'll just print out 23. Makes sense because it's well-written code, except that we're using the var, but we aren't doing anything crazy. All right, but what if we move this down here? Well, the way the JavaScript stuff, console, thank you. All right, so the way the JavaScript syntax and interpreter and stuff like that works is it moves all variable definitions to the top of their scope. So if we define a variable down here but try to access it up here, it will, and even better, let's say I have, just to completely make the point, I have var a up here and it's not 1, 2, 3, right? And down here it is 1, 2, 3. All right, so at this point, if we know about scope and we have a good idea of what the hell JavaScript is doing, we would think that putting a console log before declaring a local version of the variable, it should look up our scope chain, right? It should say not 1, 2, 3. That is not what happens. In fact, JavaScript hoists, and that's why H-O-I-S-T, hoist, not with an M, it hoists all variable declarations to the top of their scope. So under the covers, it is actually doing something like this. So in reality, you will get undefined because the variable definition inside this local scope has been moved up to the top of this scope. But the actual assignment happens after you try to reference it. So you don't get that. Do we have to use const or can we just use function example name? Yeah, you can do any of that stuff. I don't care. Const or just an actual named function that's not even saved into a variable but just defined as that. Once you're making functions inside local scope, you're probably going to want to use variables, because I think by doing like function example name open close parens, by defining it that way, I'm not positive, but and you may be able to prove me wrong here, but I think it always tries to make it in global scope. I don't know. It starts to get confusing. It's good for you to think about functions in the form of like, yes, if you want to give it a name, that's fine, but you should also save it into a variable, because at the end of the day, we mess with callbacks so often that we really need to think about passing these function pointers around as variables that get changed and accessed and called from certain scopes. So one last thing, if we use let here, if we do let a here, it will still hoist the definition up to the top, or the declaration of the variable up to the top, but it will actually throw an error and say, hey, you're trying to access it before you wrote something into it, and that's not good. So this is why we want to use let, because it kind of saves us, like here, if we used var, this would be the hardest like bug to find out. Like it's not going to throw an error, it's not going to do anything, right? And if we actually tried to say like a plus plus here, it's actually okay, well, a plus equal I, right? So this is actually going to save hi into this variable, not into this variable. And it's not going to throw any errors. It's like a terrible thing to try and troubleshoot. But if we use let, okay, well that actually, yeah, okay, so that, right? So we would expect that to write hi into this A. It does not. It writes it. It creates hi, and then hi gets overridden by that, and so hi doesn't exist anywhere. We've just thrown that away, right? It gets written into a variable that was declared but not assigned, and then we immediately overwrite it. Okay, that's about all I have time for today. I'm going to switch back to the browser and the quiz. I will put this in Slack for those of you that don't get it the first time. What is today, the 9th? All right, so this quiz is about JavaScript. The access code is orange, and you're welcome to use anything that we've talked about so far. I believe everything on that quiz can be found on the JavaScript, the language page, or links off of that page. Quiz 3 is orange. All right, I gotta go. I'll be back probably around 6:30. Y'all have a wonderful afternoon and good day.